So now we're talking about the volume of a prism. And remember, a prism is a three-dimensional solid with two congruent bases and lateral faces that are rectangles. So really, it's just like we have our cylinders that we've talked about. You know, they have two bases. But this one, it has two bases. That's important. But its sides are all rectangles of some sort. And we name a prism based on the shape of its bases. So, like this one here, it has a triangle base there and a triangle base there, and the bases are parallel to each other. So that's how you know which sides the bases are. And those are triangles, so we call that a triangular prism. In this one, all the opposite sides are all rectangles, so that's a rectangular prism. So the difference between a triangular prism and a pyramid, for example, is a pyramid has one base, whether it's a triangle or a rectangle, and they all meet, all the sides then meet at a point, right? So there aren't two parallel bases, which is the case in a prism. However, the formula for finding the volume of a prism is the exact same as finding the volume of a cylinder. Volume equals big B, which is the area of the base, times the height of the prism. So instead of using pi r squared, which we were using as the area of the base in the cylinder formula, or the cylinder volume formula, we would use volume equals big B times h. Well, what is the formula for the area of a rectangle? Length times width, right? Times height. So volume equals length times width times height, and that's how you find the area of a rectangular prism. How about over here? I'm going to erase. Maybe not. If I want to find the area of a triangular prism, volume equals big B times height. Well, what's the formula for the area of a triangle? 1/2 base times height, then times the height of the prism. So it's important to remember this height in here is different than this height on the outside, right? Because the height within the triangle formula is referring to the height of the triangle, like the actual base, that shape, it's that height. And then this height out here is referring to the height of the prism, so it would be like that height in the formula, the distance between the two bases. So let's look at an example. So if I want to calculate the volume of this, I have volume equals big B times height. The two bases, we have the triangle base here and then the one on the back side there. So those are the two triangular bases, and we know those are the bases because they're the only two that are parallel to each other. So it's a triangle, so my area formula is 1/2 base times height. So let's look at the triangle first. 1/2, the base of the triangle is this, right? So it's 5.5, and then the height of the triangle is this right here, and that's 2. And then the outside, the height of the prism, or the distance between the two bases, is 4. So we end up with 22 inches cubed. Now let's look at another example. So the volume here is volume equals big B times height. It's a rectangular prism, so we're going to have length times width times height, right? And in this one, all the sides are rectangles and they're all parallel, so it doesn't matter which one you pick to be this base part here. If you wanted to pick this side and that one to be the bases, that's fine. Or you could pick the bottom and the top or the front and the back. It doesn't matter. So I'll pick 6 times 8. So 6 times 8, which then makes the height 15. That's the distance between the two bases. So we get 6 times 8 times 15, which is 720 yards cubed. Don't forget, everything in volume is cubic units. Okay, and now let's look at a real-life application problem. So, a movie theater designs 2 bags to hold 96 cubic inches of popcorn. So, there's our volume measurement right there, 96 cubic inches. A, find the height of each bag, and B, which bag should the theater choose to reduce the amount of paper needed, and explain. So let's start with A. Let's find the height of each bag. So for bag A, we have volume equals big B times height. The volume is 96, as the word problem told us. The area of the base is going to be length times width, right? So we have 3 times 4 times this height, which is our unknown. So we get 96 equals 12h. Divide by 12, divide by 12. 8 inches is the height of bag A. So let's try, make a little bit more space. Bag B. Over here, we have volume equals area of the base times the height. We have 96 equals this. We have 4 and 4. 4 times our height is unknown. 96 equals 16 times the height. Divide each side by 16. We get 6 equals the height. So now we have to think about how to answer question part B of the question. Which bag should the theater choose to reduce the amount of paper needed? Now, is this talking about volume anymore? If we're talking about the paper that's holding the popcorn, right, that's containing the volume of popcorn that we have in the bag, what measurement are we talking about? Any guesses? Surface area. So we've solved part 1 of this problem with what we know. And in the next couple classes, we're going to use surface area to solve problems, and that's when we will come back to this problem and solve the second half. But I wanted you to see you have part of what you know at this point, and in a couple classes we'll come back and you'll be able to solve the second part of this problem with surface area. So now you're just going to try a couple practice problems, and I just want you to find the volume of each prism here. So remember, area of the base of a rectangle in a square is length times width, or for a square it's side squared, and then the area of a triangle is 1/2 base times height. Alright, I will see you guys in class.